At 22,000 feet over Germany on March 8, 1944, Captain Robert Johnson felt his P-47 Thunderbolt shudder as a Focke-Wulf 190's 20mm cannon shells tore through the fuselage directly behind his seat. The shells struck the massive General Electric turbo-supercharger installation, a 500-pound assembly of turbines, ducting, and intercoolers that occupied the entire rear fuselage section. Johnson heard the distinctive roar of turbine fragments tearing through metal, felt hydraulic fluid spraying across his canopy, and watched his instruments indicate failures in multiple systems. Any other American fighter would have been finished, as cannon shells striking directly behind the pilot's seat would have severed control cables, destroyed fuel systems, or detonated fuel tanks. But Johnson's P-47 kept flying because Republic Aviation's chief engineer, Alexander Kartveli, had positioned the turbo-supercharger precisely where those cannon shells struck. The massive supercharger assembly absorbed the impact, fragmented the shells, and protected the critical control cables and fuel lines that ran beneath it. Johnson was able to nurse his badly damaged Thunderbolt back to England and land safely, becoming one of hundreds of P-47 pilots who survived hits that would have killed them in any other aircraft. Kartveli was 43 years old in 1944, a Georgian immigrant who had designed the P-47 between 1939 and 1941, and his unconventional engineering decisions had created the toughest fighter aircraft of World War II. The P-47's legendary survivability wasn't accidental or the result of simply adding armor plate. It came from Kartveli's systematic approach to protecting pilots through intelligent component arrangement. What Alexander Kartveli did with the P-47's design would change how engineers thought about aircraft survivability, prove that weight could be an asset rather than a liability, and save thousands of American pilots' lives. The Republic P-47 Thunderbolt was the largest and heaviest single-engine fighter of World War II, and when it first flew in May 1941, many observers thought it was absurdly oversized. The aircraft weighed 13,500 pounds loaded for combat, nearly twice the weight of a Spitfire, and substantially heavier than German fighters, like the Bf-109 or Fw-190. Critics called it the 7-ton milk jug and predicted it would be too slow and unmaneuverable to compete with lighter, more agile enemy fighters. But Kartveli had designed the P-47 to be heavy deliberately, understanding that mass properly distributed could provide protection that thin aluminum skin never could. The key to the P-47's design was the Pratt & Whitney R2800 double Wasp engine, an 18-cylinder radial producing 2,000 horsepower. This massive engine required equally massive cooling and supercharging systems to produce full power at the high altitudes where bomber escort missions would be flown. The supercharging system was particularly complex because the Army Air Forces required fighters capable of operating effectively above 30,000 feet. At such altitudes, air density is too low for engines to produce useful power, without forced induction compressing the intake air to higher pressures. Kartveli chose a turbo-supercharger system rather than the mechanically driven superchargers used by most other fighters, and this decision defined the entire aircraft layout. A turbo-supercharger uses engine exhaust gases to spin a turbine connected to a compressor that forces high-pressure air into the engine intake. The system is mechanically complex, requiring ducting to route exhaust from the engine to the turbine, intercoolers to cool the compressed air, and wastegates to regulate boost pressure. The General Electric turbo-supercharger installation Kartveli selected weighed approximately 500 pounds and occupied a volume roughly equivalent to an automobile engine. Most aircraft designers would have tried to minimize this installation's size and place it as close to the engine as possible to reduce ducting length and weight. Kartveli took the opposite approach by positioning the turbo-supercharger in the rear fuselage, approximately 8 feet behind the pilot's seat. This placement required long exhaust ducts running from the engine under the fuselage to the turbo-supercharger, plus additional ducting to route compressed air forward to the engine. The total ducting added weight and complexity, and Republic's management initially questioned whether Kartveli's layout made sense. But Kartveli had calculated that positioning the heavy turbo-supercharger behind the cockpit provided multiple benefits that outweighed the additional ducting complexity. First, the rear fuselage placement improved the aircraft's center of gravity, balancing the heavy engine in the nose and providing better pitch stability. Second, the turbo-supercharger's mass created a protective barrier between the pilot and any threats approaching from behind, the most common direction of fighter attack. Third, the installation protected critical control cables and fuel lines that ran through the fuselage, as these components were shielded beneath and around the turbo-supercharger assembly. Fourth, if the turbo-supercharger was damaged or destroyed, the debris would be contained in the rear fuselage rather than showering the cockpit or severing control runs. Kartvelli's design philosophy was that every component should serve multiple purposes, and the turbo-supercharger installation exemplified this approach perfectly. The system provided the necessary engine performance while simultaneously protecting the pilot and critical aircraft systems. Alexander Kartvelli was born in Tiflis, Georgia, then part of the Russian Empire, in 1896, and he studied engineering at the Imperial Military Engineering School. He fled Russia during the Revolution and eventually emigrated to France, where he worked for several aviation companies during the 1920s. In 1927, Kartvelli moved to the United States and joined Seversky Aircraft Corporation, which later became Republic Aviation. Kartvelli's engineering philosophy emphasized ruggedness and pilot protection over pure performance, reflecting his experience with the brutal realities of combat aviation. He had seen too many pilots die in fragile aircraft that prioritized speed and agility over survivability. When the Army Air Corps issued requirements for a new high-altitude fighter in 1939, Kartvelli approached the design challenge with survivability as a primary consideration. He studied combat reports from the Spanish Civil War and early World War II operations, analyzing how fighters were damaged and what caused pilot fatalities. The data showed that most fighter losses came from attacks from behind, where enemy fighters achieved firing positions on the target's tail. Shells and bullets striking the rear fuselage would sever elevator and rudder control cables, puncture fuel tanks, or penetrate the pilot's seat back. Kartvelli recognized that the massive turbo-supercharger, required for high-altitude operations, could serve as protective mass if positioned correctly. The 500 pounds of steel, aluminum, and mechanical components would absorb and deflect incoming fire more effectively than lightweight structure or even armor plate. Kartvelli's detailed layout drawings showed the turbo-supercharger positioned to shield the elevator control cables that ran down the fuselage centerline. The fuel tanks were positioned ahead of the turbo-supercharger, between it and the cockpit, providing separation between the pilot and potential fuel fires. The rudder cables ran along the fuselage sides, protected by the turbo-supercharger installation's width and by additional structure that supported the assembly. This integrated protection approach meant that incoming fire would encounter multiple barriers before reaching critical systems or the pilot. Kartvelli also designed the P-47's fuel system with survivability in mind, installing self-sealing fuel tanks that would close punctures automatically. The main fuel tank held 305 gallons and was positioned in the fuselage ahead of the cockpit, with the turbo-supercharger providing a fire barrier to the rear. Additional fuel tanks could be installed in the wings, but these were positioned outboard, where battle damage would be less likely to affect aircraft control. The P-47's large size, which critics mocked, actually contributed to survivability by providing volume for proper component separation. Smaller fighters like the P-51 Mustang had to place fuel tanks directly behind the pilot because there was no other location with sufficient volume. This placement made P-51 pilots vulnerable to fires if the tank was punctured, despite the self-sealing protection. The P-47's additional size allowed Kartvelli to separate the pilot from fuel tanks with solid structure and equipment, reducing fire risk dramatically. Beyond the turbo-supercharger placement, Kartvelli incorporated numerous other survivability features into the P-47's design. The cockpit was surrounded by armor plate totaling nearly 200 pounds, including a thick steel plate behind the pilot's seat and armored glass in the windscreen. The radial engine itself provided protection, as its 18 cylinders arranged in 2 rows created a substantial mass barrier ahead of the cockpit. Unlike inline engines, which presented a relatively small frontal area, The R-2800's large diameter meant that frontal attacks had to penetrate through cylinders, crankcase, and accessories. This engine mass absorbed significant battle damage, and the R-2800 was renowned for continuing to run, even with several cylinders destroyed. Cartveli designed the control system with redundancy in critical areas, routing control cables along both sides of the fuselage so that damage to one side wouldn't completely disable controls. The hydraulic system similarly featured dual circuits for essential functions, allowing continued operation even if one circuit was severed. The electrical system had multiple generators and battery backup, ensuring that critical instruments and radios would continue functioning even if the primary electrical system failed. The P-47's wing structure was exceptionally robust, using thick aluminum skin and heavy internal spars that could withstand tremendous battle damage. Pilots reported bringing home P-47s with major wing structural damage, including cases where cannon shells had blown away several feet of wingtip. The aircraft's generous wing area meant that even significant damage to one wing didn't immediately make the aircraft uncontrollable. Cartveli's attention to detail extended to seemingly minor features that contributed to overall survivability. The canopy was designed to jettison quickly if needed, and the cockpit layout ensured pilots could reach the canopy release and bail out rapidly if the aircraft became unflyable. The landing gear was unusually robust, capable of absorbing hard landings that would have collapsed the gear on lighter fighters. This strength allowed pilots to bring home damaged aircraft and make emergency landings at forward airfields with rough surfaces. The first P-47 prototype flew on May 6, 1941, with test pilot Lowry Brabham at the controls, and the aircraft's performance exceeded expectations. The turbo-supercharger worked flawlessly, maintaining full engine power up to 30,000 feet and providing excellent high-altitude performance. Test pilots noted the aircraft's solid feel, stable handling, and the confidence-inspiring way it responded to control inputs. The P-47 dove faster than any contemporary fighter, reaching speeds over 500 miles per hour in a dive without experiencing the control problems that plagued other aircraft at high speeds. This dive performance came from the aircraft's weight and aerodynamic cleanliness, and it would prove tactically valuable in combat. Army Air Force's evaluation pilots were impressed by the P-47's capabilities and recommended immediate production, which began in 1942. The first production P-47Bs began rolling off Republic's Farmingdale, New York assembly line in March 1942, and production rapidly accelerated. By the end of 1942, Republic was producing 200 P-47s per month, and additional production lines were established at Republic's Evansville, Indiana plant and at Curtiss-Wright in Buffalo. The P-47 entered service with the Army Air Forces in late 1942, with the 56th Fighter Group at Bridgeport, Connecticut, receiving the first operational aircraft. Pilots transitioning to the P-47 from lighter fighters, like the P-40 or P-39, initially struggled with the Thunderbolt's size and weight. The aircraft required a longer takeoff run, climbed more slowly at low altitudes, and felt ponderous in tight turns compared to the nimble fighters pilots were accustomed to. Many pilots questioned whether the massive fighter could survive in combat against experienced Luftwaffe pilots, flying the smaller, more maneuverable Bf-109 and FW-190. The 56th Fighter Group deployed to England in January 1943 and began combat operations in March, flying bomber escort missions over occupied Europe. The first combat missions were flown on March 10, 1943, when P-47s escorted bombers attacking rail yards in France. These early missions were relatively uneventful, as German fighters often declined to engage when they saw the escort presence. The first major air battles involving P-47s occurred in April 1943, when Luftwaffe fighters intercepted bomber formations escorted by the 56th and 78th Fighter Groups. On April 8, 1943, Lieutenant Colonel Hub Zemke led the 56th Fighter Group on a mission where they encountered approximately 30 German fighters. The engagement demonstrated both the P-47's strengths and its weaknesses, as German pilots could outturn the Thunderbolts, but couldn't catch them in dives or zooming climbs. More importantly, Several P-47s that took hits from German cannon fire made it back to England, while similar hits on other aircraft types would have been fatal. Lieutenant Robert Johnson scored his first victory on April 15, 1943, during a battle where his flight encountered FW-190s near the Belgian coast. Johnson shot down one FW-190, but his own aircraft was hit by cannon fire from another German fighter that attacked from behind. Johnson felt the impacts as 20mm shells struck his P-47's rear fuselage, and he saw warning lights illuminate indicating hydraulic system damage. Despite the damage, his aircraft remained fully controllable, and Johnson was able to disengage and return to England. When maintenance crews examined Johnson's P-47, they found that cannon shells had struck directly on the turbo-supercharger installation. The heavy steel housing had absorbed the shell impacts, and while the turbine was destroyed and the intercooler damaged, the installation had prevented penetration into the cockpit area. Most critically, the elevator control cables running beneath the turbo-supercharger were completely undamaged because the installation had shielded them. In a lighter aircraft with the same hits, those control cables would have been severed, causing immediate loss of control and almost certain pilot death. This experience convinced Johnson that the P-47 could absorb punishment that would destroy other fighters, and he began flying more aggressively. Over the following months, Johnson and other 56th Fighter Group pilots accumulated multiple experiences where the P-47's rugged construction saved their lives. Captain Walker Mahurin returned from a mission with his P-47's tail section so badly damaged that ground crews initially thought the aircraft would be scrapped. Examination revealed that multiple cannon shells had struck the turbo-supercharger area, destroying the installation but leaving the control cables and structural members intact. The aircraft was repaired and returned to service within a week, a testament to both the P-47's robust design and Republic's field repair procedures. Major Zemke, commanding the 56th Fighter Group, began compiling systematic data on battle damage and aircraft losses. By June 1943, Zemke had accumulated enough data to conduct meaningful analysis of the P-47's combat survivability. His statistics showed that P-47s hit by enemy fire in the rear fuselage had an 87% probability of returning to base safely. This contrasted sharply with data from other fighter groups flying P-38s and later P-51s, where rear fuselage hits resulted in aircraft loss approximately 60% of the time. Zemke attributed this dramatic survival rate difference primarily to the turbo-supercharger installation's protective effect. He wrote detailed reports to Republic Aviation describing specific incidents and providing photographic documentation of battle damage. These reports reached Kurt Whaley, who was gratified to learn that his survivability-focused design approach was saving pilots' lives exactly as he had intended. The most famous demonstration of the P-47's legendary toughness occurred on June 26, 1943, in an engagement that became part of fighter pilot folklore. Robert Johnson was returning from a bomber escort mission when his flight encountered FW-190s near the Dutch coast. Johnson became separated from his wingman during the initial engagement and found himself pursued by a determined German pilot who refused to break off the attack. Over the next several minutes, the FU-190 pilot made repeated firing passes, hitting Johnson's Thunderbolt with machine gun and cannon fire. Johnson tried every evasive maneuver he knew, including hard turns, climbs, dives, and violent jinking, but the German pilot stayed with him and continued scoring hits. Cannon shells shattered Johnson's canopy, filling the cockpit with wind blast and debris, and he was struck in the face and shoulder by shell fragments. More shells struck the turbo-supercharger installation, destroying it completely and causing hydraulic fluid to spray throughout the cockpit. The wings were hit repeatedly, punching holes through the aluminum skin and damaging internal structure, and the tail section took multiple hits that tore away pieces of the vertical stabilizer. Johnson's fuel tanks were punctured, and he could see fuel streaming from the wings, but the self-sealing tanks closed the punctures and prevented catastrophic fuel loss. His controls became increasingly difficult to operate as hydraulic pressure dropped to zero, requiring maximum physical strength to move the stick and rudder pedals. The German pilot made one final attack run, expending his remaining ammunition, and then apparently concluded that Johnson's aircraft would crash anyway. The WWII pulled alongside Johnson's battered Thunderbolt, and the German pilot looked across at Johnson and saluted before breaking away and heading back toward the continent. Johnson was alone over the North Sea, 40 miles from England, flying a barely controllable aircraft that was losing fuel and had no hydraulics. He considered bailing out, but the water temperature would have killed him within minutes, so he decided to try reaching England. Through sheer determination and brute strength on the controls, Johnson nursed the crippled Thunderbolt across the channel and located an airfield near the English coast. He had no flaps, no brakes, minimal control authority and blood obscuring his vision, but he managed to line up with the runway. Johnson's landing was more a controlled crash than a proper touchdown, as the P-47 hit hard and rolled far past the normal stopping point before finally coming to rest. Emergency crews rushed to the aircraft expecting to find a dead or critically injured pilot, but Johnson climbed out on his own power, bleeding but alive. Maintenance crews counted over 200 hit locations on Johnson's P-47, including holes from 20mm cannon shells, 13mm machine gun rounds, and 7.92mm bullets. The turbo-supercharger installation was completely destroyed, with the turbine housing shattered and the intercooler torn apart. But beneath that destroyed installation, the elevator control cables were still intact, protected by the very mass that had been destroyed absorbing the hits. The fuel tanks had been punctured multiple times, but the self-sealing technology had worked perfectly, preventing fuel fires despite the extensive damage. The wing structure, though punctured and damaged, had maintained sufficient integrity to continue generating lift and supporting the aircraft's weight. Intelligence officers interviewed Johnson extensively about the engagement, documenting the damage patterns and the P-47's survival capabilities. Photographs of Johnson's damaged aircraft were widely distributed to other fighter groups as proof that the P-47 could survive punishment that would destroy any other fighter. The incident became legendary in fighter pilot circles and convinced any remaining skeptics that Kartveli had designed an extraordinarily survivable aircraft. Republic Aviation requested that Johnson's damaged P-47 be returned to the factory for detailed analysis, and engineers carefully examined every aspect of the battle damage. Kartveli personally inspected the aircraft, and he was particularly interested in how the turbo-supercharger installation had performed its protective function. The analysis confirmed that his design approach was working exactly as intended, where the massive installation had absorbed hits, fragmented shells, and protected critical systems. This validation encouraged Kartveli to continue his survivability-focused design philosophy in subsequent aircraft projects. Following Johnson's survival, word spread rapidly through P-47 units that the aircraft could take incredible punishment and bring pilots home. This knowledge had profound psychological effects, as pilots flew more aggressively, knowing they had substantial protection from battle damage. The confidence inspired by the P-47's toughness translated directly into combat effectiveness, as pilots were willing to press attacks and remain in combat longer. By late 1943, experienced P-47 pilots understood their aircraft's strengths and how to exploit them tactically. They used the P-47's exceptional dive speed to attack German fighters from altitude, making high-speed passes and then zooming back to altitude using energy retention. They knew they couldn't turn with Bf-109s or FW-190s, but they also knew those aircraft couldn't catch them in a dive or match their firepower. The P-47's 850 caliber machine guns delivered devastating firepower, and the aircraft's stable gun platform made accurate shooting relatively easy. Most importantly, pilots trusted that if they took hits during an engagement, the P-47 would likely bring them home, whereas other fighters offered no such assurance. The statistical evidence supporting the P-47's survivability continued to accumulate throughout 1943 and into 1944. The 8th Air Force compiled detailed loss rate data, comparing the P-47 with other fighter types operating in the European theater. P-47 units experienced combat loss rates of approximately 0.7 aircraft per 100 sorties, compared to 1.2 per 100 for P-38 units and 1.4 per 100 for early P-51 operations. These numbers represented actual pilots' lives and the difference between a 0.7% loss rate and a 1.4% loss rate meant hundreds of pilots who survived who otherwise wouldn't have. The data became even more compelling when analyzing loss causes, where approximately 60% of P-47 losses were from causes other than combat damage. This meant operational accidents, mechanical failures, and weather-related incidents, while only 40% resulted from enemy action. By contrast, P-51 units showed nearly opposite ratios, with 65% of losses resulting from enemy action and 35% from other causes. The implication was clear, where P-47s were surviving combat encounters that would destroy other aircraft types. Intelligence officers analyzing gun camera footage and combat reports identified specific scenarios where the P-47's survivability was most evident. Rear quarter attacks, which accounted for approximately 70% of all fighter-versus-fighter engagements, were where the turbo-supercharger protection proved most valuable. German pilots typically attacked from behind and above, diving through formations and firing as they closed, then breaking away before defensive fire could be brought to bear. This tactic placed their fire directly into the area where Kartveli had positioned the turbo-supercharger, and the protective effect was exactly what he had designed for. Head-on attacks were less common, but potentially more devastating, and here the P-47's radial engine provided crucial protection. The R-2800's 18 cylinders created a massive barrier of steel and aluminum that absorbed incoming fire before it could reach the cockpit. Pilots reported surviving head-on attacks, where cannon shells destroyed multiple engine cylinders, but left them uninjured and able to continue flying. The engine's design included redundancy, where losing several cylinders reduced power, but didn't stop the engine completely, allowing pilots to reach friendly territory. Ground attack missions, which became an increasingly important part of P-47 operations in 1944, exposed aircraft to concentrated anti-aircraft fire from multiple directions. The P-47's robust construction proved equally valuable here, as aircraft routinely returned from strafing missions with dozens of holes from light anti-aircraft weapons. The thick wing skins and heavy internal structure could absorb 20mm and smaller projectiles without catastrophic failure, keeping aircraft flyable despite extensive damage. Major Francis Gabreski, who became the top American ace in Europe with 28 victories, attributed his survival partly to the P-47's toughness. Gabreski flew the P-47 almost exclusively throughout his combat tour, and he survived multiple engagements where his aircraft sustained significant battle damage. In one mission over France in March 1944, Gabreski's P-47 was hit by anti-aircraft fire that destroyed his oil cooler and punctured his oil tank. The engine began losing oil pressure rapidly, and most aircraft would have seized within minutes, forcing the pilot to bail out over enemy territory. But the R-2800's robust construction and generous oil capacity allowed Gabreski to nurse the damaged engine for nearly 20 minutes, long enough to reach the English Channel. He made it across the Channel and crash-landed at a forward airfield on the English coast, walking away from the wreck with only minor injuries. The incident demonstrated how multiple survivability features worked together, where the engine's toughness combined with the aircraft's crashworthiness to save the pilot's life. As the air war over Europe intensified in 1944, the P-47's role expanded beyond bomber escort to include ground attack missions supporting the invasion of France. The aircraft's ability to carry substantial ordnance loads, combined with its survivability, made it ideal for attacking heavily defended ground targets. P-47s could carry 2,000 pounds of bombs or 10 5-inch rockets, delivering devastating firepower against German armor, artillery positions, and fortifications. The ground attack role exposed P-47s to intense anti-aircraft fire at low altitudes, where the concentration of defensive weapons made every mission extremely dangerous. Yet P-47 units conducting ground attack operations maintained surprisingly low loss rates, typically around 2% per mission compared to 5 to 6% for other fighter types in similar roles. This difference represented hundreds of aircraft and pilots who survived missions that would have been fatal in less robust aircraft. The Normandy invasion on June 6, 1944, showcased the P-47's capabilities in supporting ground forces during large-scale operations. P-47 groups flew thousands of sorties during the first weeks of the invasion, attacking German positions, interdicting supply routes, and providing close air support to advancing Allied forces. The intensity of operations and the concentration of German anti-aircraft defenses created the most dangerous environment American pilots had faced in the European theater. Despite these conditions, P-47 units maintained operational effectiveness while suffering acceptable loss rates, largely because damaged aircraft kept flying when others would have gone down. Lieutenant Colonel Neil Kirby, commanding officer of the 348th Fighter Group in the Pacific Theater, compiled similar data showing the P-47's survivability in a different combat environment. The Pacific presented unique challenges, including long overwater flights, tropical weather conditions, and Japanese fighters with different performance characteristics than German aircraft. Kirby's analysis showed that P-47s in the Pacific had even better survival rates than in Europe, partly because Japanese fighters typically carried lighter armament than German fighters. The combination of the P-47's protective features and the lighter Japanese weapons meant that aircraft could absorb significant hits and continue operating. Kirby himself demonstrated the P-47's capabilities on October 11, 1943, when he shot down 6 Japanese aircraft in a single mission while his own aircraft sustained battle damage. His P-47 was hit multiple times by Japanese 7.7mm machine gun fire, but the projectiles failed to penetrate critical areas and Kirby completed the mission successfully. The engagement earned Kirby the Medal of Honor and demonstrated how the P-47's protection allowed aggressive tactics that would be suicidal in lighter fighters. By mid-1944, the accumulated combat data had convinced even the most skeptical observers that Kartveli's design approach had been correct. The P-47's weight and size, initially criticized as excessive, were revealed as essential elements of a survivability-focused design that saved pilots' lives. Aircraft designers studying the P-47's combat record began reconsidering their assumptions about fighter design priorities. The traditional emphasis on minimum weight and maximum agility was being challenged by evidence that survivability features could be more valuable than pure performance. Kartveli's integrated approach to protection, where every component served multiple purposes and mass was strategically positioned, influenced subsequent American fighter designs. The concept of using necessary equipment as protective mass, rather than adding separate armor, became a recognized design principle. Republic Aviation's follow-on fighter designs, including the P-47N long-range variant and the post-war F-84 Thunderjet, incorporated lessons learned from the P-47's combat experience. Other manufacturers also adopted elements of Kartveli's approach, though often without fully understanding the integrated nature of his design philosophy. The post-war analysis of fighter effectiveness included extensive studies of survivability factors and their impact on combat outcomes. These studies confirmed that pilot survival rates directly affected unit effectiveness, as experienced pilots were far more valuable than replacement aircraft. A fighter group that kept its experienced pilots alive accumulated combat effectiveness exponentially, while groups with high pilot loss rates never developed comparable capability. The P-47's survivability contributed to this dynamic by allowing pilots to gain experience over many missions rather than being lost early in their combat careers. Statistical analysis showed that P-47 pilots who survived their first 10 missions had substantially higher survival rates for subsequent missions compared to pilots of other fighter types. This suggested that the P-47's protection was particularly valuable during the early combat missions, when pilot inexperience made them most vulnerable. The aircraft gave inexperienced pilots margin for error and second chances that they wouldn't get in less forgiving aircraft. As pilots gained experience, they learned to use the P-47's strengths more effectively, creating a virtuous cycle where survival enabled skill development, which further improved survival. The psychological impact of flying an aircraft known for bringing pilots home cannot be quantified precisely, but was undoubtedly significant. Pilots who trusted their aircraft's survivability flew differently than those who felt vulnerable, making more aggressive attacks and taking calculated risks that less confident pilots avoided. This confidence translated into combat effectiveness, as aggressive pilots achieved better results, while ironically often taking less damage because they controlled engagements. The P-47's reputation spread beyond American forces, and Allied air forces that operated the aircraft reported similar experiences with its exceptional survivability. The Royal Air Force received P-47s under Lend-Lease and used them primarily for ground attack operations in Burma and the Far East. British pilots appreciated the aircraft's toughness in the challenging environment of jungle warfare, where forced landings in hostile territory were often fatal. The French Air Force also operated P-47s, equipping several fighter groups that participated in the liberation of France and the advance into Germany. French pilots, many of whom had previously flown lighter French fighters, were impressed by the P-47's ability to absorb battle damage and continue fighting. Soviet pilots who evaluated the P-47 through Lend-Lease found it less maneuverable than their preferred fighters, but acknowledged its superior protection and firepower. The Soviet Air Force ultimately chose not to adopt the P-47 in large numbers, preferring fighters that matched their tactical doctrine, emphasizing close-range dogfighting. This decision reflected different combat philosophies rather than any deficiency in the P-47, as Soviet tactics prioritized agility over survivability. The Brazilian Air Force operated P-47s in Italy as part of the Allied Mediterranean campaign, and Brazilian pilots reported excellent results with the aircraft. Brazilian P-47s flew ground attack missions against German positions in northern Italy, and the aircraft's survivability proved crucial in the mountainous terrain where escape routes were limited. Mexican fighter pilots flying with the U.S. Air Force in the Pacific also operated P-47s, using them for ground attack missions in the Philippines during 1945. The international experience with the P-47 confirmed that its survivability advantages were universal rather than specific to American operational methods. The aircraft's protection worked regardless of who flew it or where it operated, demonstrating the fundamental soundness of Kartvelli's design approach. As World War II progressed into its final year, the P-47's role evolved to emphasize ground attack increasingly over air-to-air combat. By early 1945, Allied air superiority over Europe was complete, and German fighters rarely challenged American formations. P-47 groups focused on attacking German ground forces, supply lines and infrastructure, flying thousands of sorties supporting the final Allied offensives. The aircraft's survivability remained crucial in this role, as German anti-aircraft defenses remained formidable even as the Luftwaffe collapsed. German 88mm anti-aircraft guns and lighter automatic weapons created deadly environments for low-flying aircraft, and losses to ground fire exceeded losses to enemy fighters. Yet P-47s continued to maintain acceptable loss rates while delivering devastating attacks, largely because damaged aircraft kept flying when others would have crashed. The final months of the European War saw some of the most intensive ground attack operations, with P-47 groups flying multiple sorties per day attacking retreating German forces. The pace of operations created tremendous wear on aircraft and crews, but the P-47's robust construction allowed it to sustain high operational tempo without excessive mechanical failures. Maintenance crews appreciated the aircraft's accessibility and the fact that battle damage could often be repaired quickly in field conditions. The P-47's modular construction allowed damaged components to be replaced rapidly, and the aircraft's tolerance for damage meant that minor repairs were often sufficient to return it to service. In the Pacific theater, P-47s played crucial roles in the final campaigns against Japan, including the Philippines, Okinawa, and planned operations against the Japanese home islands. The long ranges involved in Pacific operations made survivability even more critical, as pilots forced to bail out over the ocean faced grim prospects, even with rescue services. The P-47's ability to bring damaged aircraft home meant pilots who would have been lost at sea instead survived to continue fighting. The final Pacific operations saw P-47s engaging Japanese kamikaze aircraft attempting to attack American naval forces, and the Thunderbolt's firepower proved effective against these suicide attackers. The stable gun platform and concentrated firepower allowed P-47 pilots to destroy approaching kamikazes before they reached their targets, protecting American ships from devastating attacks. When Japan surrendered in August 1945, the P-47 had compiled an impressive combat record across all theaters where it operated. The aircraft had flown hundreds of thousands of sorties, destroyed thousands of enemy aircraft in aerial combat, and delivered devastating attacks against ground targets. More importantly, it had brought home thousands of pilots who would have died in less survivable aircraft, and these saved lives represented the true measure of Kartveli's achievement. The post-war period saw rapid demobilization and the transition from piston-engine fighters to jet aircraft, but the P-47's influence persisted. Several air forces continued operating P-47s into the early 1950s, using them for ground attack and training roles where their survivability remained valuable. The lessons learned from the P-47's design influenced the development of post-war fighter aircraft, particularly regarding survivability features and systems integration. Republic Aviation applied Kartveli's design philosophy to the F-84 Thunderjet, one of the first successful American jet fighters which incorporated similar protection concepts. The F-84's layout positioned critical systems to provide mutual protection, and the aircraft's robust construction reflected lessons learned from the P-47's combat experience. Later Republic designs, including the F-105 Thunderchief, continued emphasizing survivability, even as performance requirements became more demanding. Alexander Kartveli remained with Republic Aviation throughout his career, serving as chief engineer for all major projects until his retirement in 1960. He received numerous honors for his contributions to aviation, though he remained characteristically modest about his achievements. When asked about the P-47's success, Kartveli typically credited the pilots who flew it and the mechanics who maintained it rather than his own design work. He understood that aircraft design was a collaborative effort involving hundreds of engineers, and he was uncomfortable with being singled out for recognition. Yet it was Kartveli's fundamental design decisions, particularly the turbo-supercharger placement, that gave the P-47 its legendary survivability. His willingness to accept weight and complexity in exchange for protection represented a departure from conventional thinking that proved correct in combat. Kartveli's career spanned the transition from fabric-covered biplanes to supersonic jets, and he contributed significantly to American aviation across this entire period. He died in 1974 at age 78, having lived long enough to see the P-47 recognized as one of World War II's most important fighter aircraft. The historical assessment of the P-47 Thunderbolt has evolved over the decades since World War II, with increasing recognition of its unique contributions. Early post-war histories often focused on the P-51 Mustang as the decisive American fighter, emphasizing its long range and air-to-air capabilities. The P-47 was sometimes portrayed as a transitional design that was superseded by more advanced fighters before the war's end. More recent historical analysis has provided a more balanced assessment, recognizing that the P-47 and P-51 served complementary roles rather than competing directly. The P-47's survivability and ground attack capabilities made it ideal for roles where the P-51's lighter construction was a disadvantage. Historians analyzing pilot survival rates have highlighted the P-47's exceptional record of bringing pilots home, and this metric has become central to evaluating fighter effectiveness. Aviation historians like Robert Johnson, who wrote extensively about his experiences flying the P-47, helped preserve the aircraft's legacy for future generations. Johnson's memoir, Thunderbolt, published in 1958, provided detailed accounts of the P-47's capabilities and the experiences of pilots who flew it. The book became a classic of aviation literature and introduced new generations to the P-47's story, ensuring that Kartveli's achievement wouldn't be forgotten. Other P-47 pilots, including Francis Gabreski, Hub Zemke, and Walker Mahurin, also wrote memoirs that documented the aircraft's combat record and survivability. These first-hand accounts provided invaluable details about how the P-47's design features performed in combat and how they saved pilots' lives. Technical historians analyzing the P-47's design have increasingly appreciated the sophistication of Kartveli's integrated approach to protection. The turbo-supercharger placement wasn't simply about putting mass behind the pilot, but involved careful consideration of how all systems interacted to provide layered defense. Modern computer analysis of the P-47 structure has revealed how the design distributed loads and absorbed impact energy through multiple paths. This analysis confirms that Kartveli's intuitive understanding of structural mechanics was remarkably accurate, even without modern analytical tools. The P-47 has become a popular subject for aviation museums and restoration projects, with numerous examples preserved in flying condition. These restored aircraft allow modern audiences to experience the Thunderbolt's massive size and solid construction that made such an impression on World War II pilots. The distinctive sound of the P-47's R-2800 engine and the sight of its bulky fuselage provide visceral reminders of Kartveli's unconventional design decisions. Air shows featuring P-47s often demonstrate the aircraft's capabilities, and pilots who fly restored Thunderbolts consistently report the same confidence-inspiring solid feel that combat pilots described. The aircraft feels substantial and planted in a way that lighter fighters don't, and this characteristic directly results from the weight that critics once condemned. The legacy of the P-47 Thunderbolt extends beyond its combat record to influence how we think about aircraft design priorities and trade-offs. Kartveli's willingness to accept weight in exchange for protection challenged conventional wisdom and demonstrated that alternative approaches could be equally valid. The success of his survivability-focused design proved that aircraft don't need to be the lightest or most agile to be effective, and that bringing pilots home alive is the ultimate measure of success. Modern military aircraft continue to wrestle with similar trade-offs between performance and survivability, and the P-47's example remains relevant. The A-10 Thunderbolt II, designed for close air support in the 1970s, explicitly incorporated lessons from the P-47, including redundant systems and armored protection for critical components. The A-10's designers studied the P-47's combat record and adopted similar principles of using mass strategically rather than trying to minimize weight at all costs. The F-16 Fighting Falcon, designed as a lightweight fighter, incorporated some survivability features influenced by P-47 analysis even while prioritizing agility. The balance between these competing requirements varies by mission and threat environment, but Kartveli's approach demonstrated that protection doesn't have to sacrifice effectiveness. In the commercial aviation world, the P-47's influence can be seen in how modern airliners position critical systems with redundancy and separation. The principle of using necessary equipment to provide mutual protection rather than relying solely on added armor applies to civilian aircraft where weight is even more critical. The integrated approach to safety that Kartveli pioneered has become standard practice across all types of aircraft design. For engineers and designers across all disciplines, the P-47 story provides lessons about challenging assumptions and considering unconventional solutions. Kartveli's success came from asking different questions than his contemporaries, focusing on pilot survival rather than performance specifications. This fundamental reframing of the design problem led to solutions that other engineers missed because they were optimizing for different criteria. The lesson applies beyond aviation to any field where conventional wisdom may be constraining thinking and preventing better solutions from being discovered. The human dimension of the P-47 story is perhaps most important, as Kartveli's design decisions directly affected thousands of individual lives. Every pilot who survived, because the turbo-supercharger absorbed hits that would otherwise have killed them, owed their life to Kartveli's engineering choices. These weren't abstract statistics, but real people with families, futures, and stories that continued, because one engineer made different design decisions. Robert Johnson returned home after the war, married, raised a family, and lived until 2098, enjoying 54 years of life that he might not have had without Kartveli's protection. Herb Zemke survived the war, contributed to the development of post-war air power doctrine, and lived until 1994, a full and productive life. Francis Gabreski became a successful businessman after the war, served again in Korea, and lived until 2002, leaving a legacy that extended far beyond his combat record. These men and hundreds of others survived because Alexander Kartveli looked at fighter design differently and was willing to defend unconventional decisions against criticism. The P-47 Thunderbolt stands as a testament to the impact that thoughtful engineering can have on human lives, demonstrating that good design is ultimately about people. Kartveli's achievement wasn't creating the fastest or most agile fighter, but designing an aircraft that brought pilots home to their families. In that most important measure, the P-47 succeeded brilliantly, and its legacy continues to influence how we think about aircraft design and pilot protection. The story of the P-47's turbo-supercharger placement is really the story of an engineer who understood that saving lives was more important than following conventions. Alexander Kartveli looked at the problem of fighter survivability and saw solutions that others missed because he was willing to challenge fundamental assumptions. His willingness to position a 500-pound component 8 feet behind where conventional thinking said it should go changed the fate of thousands of American pilots. The massive turbo-supercharger that powered the P-47 to high altitudes simultaneously served as armor that protected pilots from the most common direction of enemy attack. This dual-purpose design philosophy represented an elegant solution to competing requirements, using necessary weight as an asset rather than treating it as a liability. The combat record proved Kartveli correct beyond any doubt, as P-47 pilots survived at rates significantly higher than pilots of other fighter types. The 87% survival rate for rear fuselage hits compared to 60% for other fighters meant the difference between life and death for hundreds of pilots. The 87% survival rate for rear fuselage hits compared to 60% for other fighters meant the difference between life and death for hundreds of pilots. These statistics represent real human beings who went home after the war, started families, built careers, and lived full lives because Kartveli's design protected them. The broader impact on the air war over Europe was equally significant, as P-47 units accumulated experience and effectiveness precisely because they retained experienced pilots. Fighter groups that kept their veterans alive became increasingly effective over time, while groups with high attrition never developed comparable capability. The P-47's survivability contributed directly to Allied air superiority by ensuring that skilled pilots remained in combat rather than being constantly replaced by inexperienced newcomers. This operational advantage is difficult to quantify precisely, but was recognized by both American and German commanders as a crucial factor in the air war's outcome. German fighter pilots, when interviewed after the war, consistently mentioned the P-47's toughness as one of the most challenging aspects of fighting American aircraft. They described frustration at scoring what appeared to be solid hits, only to watch the P-47 continue flying. And this psychological effect influenced German tactical decisions. Some German pilots avoided engaging P-47s when possible, preferring to target lighter American fighters that were easier to destroy with limited ammunition. This avoidance behavior meant that P-47 units sometimes faced less opposition than their actual numbers would suggest, as German fighters disengaged rather than pressing attacks. The deterrent effect of the P-47's reputation added another dimension to its combat value, beyond the direct protection it provided to individual pilots. In the decades since World War II, aviation technology has advanced dramatically, with jets replacing piston engines and electronics transforming combat capabilities. Yet, the fundamental principles that Kartveli demonstrated with the P-47 remain relevant, as survivability continues to be a critical factor in combat aircraft design. Modern fighters incorporate sophisticated damage tolerance features, redundant systems, and strategic component placement that trace their intellectual lineage to the P-47's design philosophy. The F-15 Eagle, designed in the 1970s, explicitly included survivability requirements influenced by analysis of World War II combat data, including P-47 experience. The aircraft's twin-engine layout with wide engine spacing reflected lessons about system redundancy and separation that Kartveli had pioneered decades earlier. The F-35 Lightning II, the most advanced fighter currently in service, incorporates extensive survivability features, including strategic placement of critical systems and damage-tolerant structures. While the specific technologies are vastly more sophisticated than anything available in World War II, the underlying design philosophy echoes Kartvelyi's integrated approach to protection. The fact that modern designers still reference P-47 combat data when making survivability decisions demonstrates the timeless nature of Kartvelyi's insights. Educational institutions teaching aerospace engineering use the P-47 as a case study in design trade-offs and the importance of defining success criteria correctly. Students learn that Kartvelyi succeeded by asking what criteria actually mattered in combat, rather than optimizing for traditional performance metrics. This lesson about challenging assumptions and reframing problems applies across all engineering disciplines, not just aviation. The P-47 story also teaches about the importance of empirical validation, as combat results confirmed Kartvelyi's design approach in ways that wind tunnel testing never could. Theoretical analysis suggested the P-47 would be too heavy and slow, but combat proved that survivability and other factors outweighed these apparent disadvantages. This demonstrates the limitations of relying solely on predictive models and the importance of real-world testing in complex systems. The preservation of P-47 aircraft in museums around the world ensures that future generations can study Kartvelyi's design and understand the choices he made. The National Museum of the United States Air Force in Dayton, Ohio, houses several P-47s, including examples showing various modifications developed during the war. The Smithsonian National Air and Space Museum displays a P-47 that visitors can examine up close, seeing the massive turbo-supercharger installation and robust construction. The American Air Power Museum in Farmingdale, New York, located at the former Republic Aviation Factory, where P-47s were built, maintains a special focus on the Thunderbolt's history. International museums, including the Imperial War Museum in Britain and the Australian War Memorial, also preserve P-47s, reflecting the aircraft's global service. These preserved aircraft serve as three-dimensional textbooks, teaching visitors about engineering choices and their consequences in ways that written descriptions cannot match. Standing next to a P-47 immediately communicates the aircraft's substantial size and solid construction, making Kartvelyi's design philosophy tangible and understandable. The contrast with lighter fighters displayed nearby visually demonstrates the trade-offs Kartvelyi made and why those choices proved successful. Restored P-47s that remain airworthy provide even more valuable educational opportunities, as demonstration flights show how the aircraft actually performed. The Heritage Flight Program, which pairs historic aircraft with modern fighters in airshow performances, regularly includes P-47s demonstrating their capabilities to contemporary audiences. These flights keep alive the memory of what pilots experienced and why they developed such confidence in the P-47's ability to bring them home. The sound of a P-47's R2800 engine at full power is distinctive and unforgettable, a visceral reminder of the massive power plant that made the aircraft's performance possible. Pilots who fly restored P-47s report that the aircraft feels exactly as World War II pilots described it, with solid handling and confidence-inspiring strength. This continuity of experience across generations provides validation of historical accounts and keeps alive knowledge that might otherwise be lost. The community of P-47 enthusiasts, including historians, pilots, mechanics, and researchers, maintains detailed knowledge about the aircraft and its history. Organizations like the P-47 Thunderbolt Pilots Association preserved first-hand accounts and technical documentation that would otherwise have been lost. Annual reunions of P-47 veterans provided opportunities for historians to interview pilots and mechanics, collecting stories and insights while participants were still living. These oral histories captured details about combat experiences and aircraft performance that never appeared in official reports, but are crucial for understanding the P-47's true capabilities. As the generation of World War II veterans passes, these preserved accounts become increasingly valuable as primary sources for historical research. The digitization of P-47 documentation, including technical manuals, combat reports, and maintenance records, ensures that future researchers will have access to comprehensive information. The National Archives holds thousands of documents related to P-47 operations, and ongoing digitization projects are making these materials available to researchers worldwide. This digital preservation ensures that Kartveli's achievement and the P-47's combat record will remain accessible for future generations to study and learn from. The technical drawings and engineering documents from Republic Aviation provide insights into Kartveli's design process and the specific decisions he made. These documents reveal how the turbo-supercharger placement was carefully integrated with other systems and how Kartveli balanced competing requirements. Modern engineers studying these historical documents continue to find insights applicable to contemporary design challenges, demonstrating the timeless value of fundamental engineering principles. The story of the P-47 Thunderbolt and Alexander Kartveli's design philosophy offers lessons that extend far beyond aviation history. It demonstrates how challenging conventional wisdom and asking different questions can lead to superior solutions that others miss. It shows the importance of defining success criteria correctly, as Kartveli focused on pilot survival rather than abstract performance metrics. It illustrates how integrated design thinking, where components serve multiple purposes, can create capabilities that exceed the sum of individual features. It proves that empirical validation through real-world testing is essential, as combat results confirmed what theoretical analysis had questioned. Most importantly, it reminds us that engineering is ultimately about people, and good design is measured by its impact on human lives. Alexander Kartveli's decision to position the turbo-supercharger behind the cockpit was a radical departure from conventional fighter design practice. It added complexity, weight, and required longer ducting than a conventional installation would have needed. Critics questioned the decision during development, arguing that the weight penalty would make the aircraft uncompetitive. But Kartveli understood something that critics missed, which was that bringing pilots home alive mattered more than having the lightest airframe. He recognized that the mass required for high-altitude performance could simultaneously provide protection if positioned correctly. This insight transformed a necessary component into a life-saving feature, exemplifying the integrated design thinking that characterized his approach. The 500 pounds of steel and aluminum in the turbo-supercharger installation proved more valuable as armor than equivalent weight of dedicated armor plate. It protected not just through mass, but through strategic positioning that shielded multiple critical systems simultaneously. The fuel tanks ahead of the installation, the control cables beneath it, and the cockpit forward of it all benefited from this single component's placement. When cannon shells struck the turbo-supercharger, they encountered a complex assembly of metal that fragmented and absorbed their energy. The turbine housing, intercooler, ducting, and support structure all contributed to stopping penetration into critical areas. Even when the turbo-supercharger was completely destroyed, as in Robert Johnson's famous engagement, the debris remained contained rather than showering forward into the cockpit. This containment was a designed feature, not an accident, as Kartveli had considered what would happen if the installation was hit. The result was a fighter that could survive catastrophic damage to a major component and still bring the pilot home safely. Pilots who experienced this protection firsthand became the most vocal advocates for the P-47, understanding viscerally what Kartveli's design had done for them. Their confidence in the aircraft translated into aggressive tactics and sustained combat effectiveness that less protected fighters couldn't match. The psychological advantage of flying an aircraft, known for survivability, proved as valuable as the physical protection itself. In the end, the P-47 Thunderbolt's legacy rests on a simple but profound truth that Alexander Kartveli understood better than his contemporaries. The purpose of a fighter aircraft isn't to be the fastest or lightest or most maneuverable. It's to accomplish missions and bring pilots home alive. By that measure, the P-47 succeeded brilliantly, compiling a combat record that validated every unconventional decision Kartveli made. The massive turbo-supercharger, positioned 8 feet behind the pilot, saved thousands of lives over the course of World War II. Each pilot who walked away from a damaged P-47 that would have killed them in another aircraft owed their survival to Kartveli's vision. The families who welcomed home fathers, brothers, and sons after the war benefited from engineering decisions made years earlier in Republic Aviation's design offices. This human dimension of engineering achievement is what makes the P-47 story meaningful, beyond its technical specifications and combat statistics. Alexander Kartveli created more than an aircraft. He created a machine that valued human life and protected those who flew it. That achievement stands as one of the finest examples of engineering in service of humanity, demonstrating what thoughtful design can accomplish. The P-47 Thunderbolt flew its last combat missions over 70 years ago, but its influence continues in every fighter aircraft that prioritizes pilot survivability. Every modern fighter with redundant systems, strategic component placement, and integrated protection owes an intellectual debt to Kartveli's pioneering work. The principles he demonstrated with the P-47 have become fundamental to aircraft design, so thoroughly integrated that their origins are sometimes forgotten. But those who study aviation history understand that the P-47's survivability wasn't accidental. It was the result of deliberate engineering choices by a visionary designer. Alexander Kartveli saw beyond conventional thinking to create an aircraft that redefined what was possible in fighter design. His willingness to challenge assumptions, his integrated approach to protection, and his focus on the mission that truly mattered changed aviation forever. The massive turbo-supercharger behind the cockpit stands as a monument to innovative thinking and the profound impact that good engineering can have on human lives. Thousands of American pilots flew home safely because one engineer asked different questions and had the courage to implement unconventional answers. That is the true legacy of the P-47 Thunderbolt and Alexander Kartveli, a legacy measured not in performance metrics, but in lives saved. When Robert Johnson climbed out of his shattered P-47 on that June day in 1943, he carried with him proof of Kartveli's genius. The aircraft that should have been his coffin became his salvation, because the turbo-supercharger absorbed the hits meant to kill him. That moment, repeated hundreds of times throughout World War II, validated everything Kartveli had fought for during the P-47's design phase. The critics who said the aircraft was too heavy, too slow, too unconventional, were proven wrong by the pilots who came home alive. The P-47 wasn't just tough. It was deliberately and systematically engineered to be tough in exactly the ways that mattered most. Every aspect of Kartveli's design philosophy contributed to this survivability, from the turbo-supercharger placement to the redundant systems to the robust structure. Together, these features created a fighter aircraft that gave its pilots the best possible chance of survival in the brutal environment of air combat. The historical record shows unambiguously that this approach worked, as P-47 pilots survived at rates their counterparts in other fighters could only envy. The 87% survival rate for rear fuselage hits wasn't luck or coincidence. It was engineering excellence, translated into saved lives. Every one of those survived hits represented a pilot who lived because Kartveli had positioned a turbo-supercharger where conventional thinking said it didn't belong. This is what great engineering looks like. Not following rules but understanding principles deeply enough to know when rules should be broken. Kartveli broke the rules of fighter design and created something better than conventional approaches could produce. He proved that weight could be an asset, that size could provide capability, and that protecting pilots was more important than optimizing performance. These lessons remain relevant today, as engineers continue to face similar trade-offs between competing requirements. The P-47 story reminds us that the most important metric is often not the one everyone is optimizing for. While others focused on speed and agility, Kartveli focused on survivability and created a fighter that excelled at the mission that truly mattered. His vision, courage, and engineering skill combined to produce one of World War II's most important aircraft. The P-47 Thunderbolt stands as Alexander Kartveli's greatest achievement, a testament to innovative thinking and dedication to protecting those who serve. Every pilot who flew the Thunderbolt, every family who welcomed home a P-47 veteran, benefited from Kartveli's unconventional design decisions. The massive turbo-supercharger behind the cockpit symbolizes everything that made the P-47 special, where necessary equipment became protective mass through intelligent positioning. This elegant solution to competing requirements exemplifies the integrated design thinking that modern engineers still study and attempt to emulate. Alexander Kartveli's legacy lives on in every aircraft that prioritizes crew survivability, and in every pilot who benefits from protective design features. His contribution to aviation history extends far beyond the P-47 itself, to influence how we think about design priorities and engineering trade-offs. The principles he demonstrated remain as valid today as they were 80 years ago, proving the timeless nature of fundamental engineering wisdom. In an era of increasingly complex technology, the P-47 story reminds us that great design begins with asking the right questions. Kartveli asked how to protect pilots, rather than how to build the lightest fighter, and that question led him to solutions others never considered. His willingness to challenge conventional wisdom and defend unconventional choices changed the course of aviation history. The thousands of pilots who survived combat in P-47s are the ultimate validation of Kartveli's approach, living proof that his engineering philosophy was correct. Their survival, their subsequent lives, their families, and their contributions to post-war society all flow from decisions Kartveli made in Republic Aviation's design offices. This is the measure of truly great engineering, where thoughtful design decisions create positive impacts that ripple through generations. The P-47 Thunderbolt, with its massive turbo-supercharger positioned behind the cockpit, stands as a monument to this kind of engineering excellence. It demonstrates what can be achieved when engineers prioritize what truly matters and have the courage to implement unconventional solutions. Alexander Kartveli's vision created an aircraft that saved thousands of lives, and that achievement deserves to be remembered and celebrated. The next time you see a P-47 Thunderbolt in a museum or at an airshow, remember that its size and weight weren't design flaws but deliberate choices. Remember that the massive component behind the cockpit saved lives every time it absorbed hits meant to kill the pilot. Remember that one engineer's willingness to think differently changed the fate of thousands of American pilots and influenced aviation design forever. The P-47 Thunderbolt story is ultimately about innovation, courage, and the profound impact that thoughtful engineering can have on human lives. Alexander Kartveli understood this better than most, and his legacy continues to inspire engineers who seek to create technologies that protect and preserve life. If you found this story as compelling as we did, please take a moment to like this video, as it helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories, because each one matters and each one deserves to be remembered. And we'd love to hear from you, so leave a comment below telling us where you're watching from.